thought I might actually start this lesson by quickly having a look at your information sheet. Why not? And as it was last year, your trig section here has some stuff that you don't need to memorize, but it's kind of good for you to know how it works out this way. We've started to cover the cast diagram again, so I'll return to that in a second. You can see that the multiplication factor for radians, degrees, or vice versa is also given to you. I'm pretty sure we covered this basic identity last year in Methods 3, did we not? Yeah, but I'll cover it again briefly this year as well. This one we definitely did, and I covered it last lesson. These are new, sec and cosec. So you know that sin is not pronounced sin, it's sine, S-I-N-E, and that cos is not cos, it's cosine, right? You know that, I hope. And that tan is not tan, it's actually short for tangent, the tangent function. And you can see these are basically the inverses of those three. So this is cotangent, 1 on tan x. This is secant, 1 on cos x. And this is cosecant, which is 1 on sine x. And effectively, it completes the different ratios. Like, you know, if tan is, I'll choose sine. If sine is opposite over hypotenuse, then cosec is hypotenuse over opposite, right? 1 on, so it flips it. Secant is hypotenuse over adjacent. And cotangent or cotan is adjacent over opposite. So it actually completes the set of all the different ratios in a right-angled triangle, which we then extend through to angles above 90 degrees. Yeah, and then, of course, this is the other important thing, which you should have seen last year as well, and I'm going to talk about it briefly again, is this exact value chart. At some point, I'd like to just show you this on a triangle because it's kind of important for further work that we do. But effectively, you're given them. The more you can remember, the better. I can never remember them. So I don't actually apply a chart, though. I just quickly draw up a triangle and work it out from a triangle because it takes me like 5 seconds work to do that rather than trying to find the value on a chart. For me, it just doesn't work for my brain. But they're there is the important point. So if you're ever asked to find out what the cosine of pi on 4 is, you can go, oh, it's root 2 on 2 from this table. And that's a given. That, you know, I won't be testing you on that. But again, the more you know, the more fluent you can become in your maths. So that's the exact values chart, which is going to be important in a tickie. So where we ended last lesson was talking about this idea beyond 90 degrees. We have an angle beyond 90 degrees. We are going to re-establish our brain to be thinking about cosine and sine as the x and y coordinate of the unit graph, okay, the unit circle. So this red line here is a line of length 1. It's away from the x-axis in an anti-clockwise direction. It's away from the x-axis by an angle of theta, and that gives us a unique xy position. So we can see that in obtuse land, so between pi and pi on 2, in obtuse land, theta would give us a negative x coordinate and a positive y coordinate, okay, which means cosine is negative and sine is positive. So just remember from last lesson, really briefly, that effectively the way we've defined it is by looking at the first quadrant, by seeing that if I have a unit, a hypotenuse of length 1, then effectively the x distance becomes the adjacent of the right angle triangle, and the opposite side would be the y distance, and therefore at the top here we would have x comma y, and so that becomes our coordinate. So that when I go, if I take that angle there, that acute angle there, and flip it over to this side, I get this, don't I? I get that angle there. The angle from x would therefore be obtuse, And because it was a flip from there to here, I'm effectively going to have the same values of coordinates, x and y. It's just that x will be negative instead of positive. So we have this relationship between the acute angle that is formed between the x-axis and the unit line and the coordinates. So what I am trying to train you to doing, and this is the way I teach. I teach my methods 3, my methods 4, my maths AA. It is not my method, but it is a method. Jane teaches differently, for example. So if this is really not gelling, you can watch Jane's videos from her class and it'll be different. So what I teach, though, is that when you've got an angle that's beyond 90 degrees, consider the acute angle. Figure the acute angle out. Therefore, you can work out the xy coordinate from the acute angle, and then you just need to work out whether it's negative or positive. Okay? So, and that's what the rest of this was all about. That's where we got to yesterday. Importantly, though, we tend to forget the xy coordinate system, and we tend to use the cast diagram. Can't remember whether it's on the next page or not. Yeah, we tend to use this diagram as well, which is on your formula sheet. All students take care, South Australian Technical College, however you want to do it. And we just tend to remember sine is positive here, tan is negative, positive here, cosine is positive here, and everything is positive in the first quadrant. But it's really important to remember that effectively why this works is because sine is the y coordinate. So therefore it's going to be positive above the x-axis, there and there. Cosine is the x coordinate. Therefore, cosine is going to be positive to the right of the y-axis, so here and here. Tan is the gradient, and it means that it's going to be positive when we've got the direction of the line going left to right up. So hence, it's these two here. Keep that in mind, please, because when we start doing more complex stuff, remembering that it's effectively a system of coordinates is really going to help you when it comes to doing your further mathematics here. Okay, so I just wanted to show briefly that other quadrants. So if I have a third quadrant, so first, second, third, fourth, if I have a third quadrant angle, so this is these two are reflex angles, aren't they? So that means it's a beyond pi, but below 3 pi on 2. So if it's a third quadrant angle, theta hat, that acute angle, is between the x-axis and this line here. And then if it is an angle between 3 pi on 2 and 2 pi, then it will be theta all the way around here, and the acute angle will be formed between the unit line and the x-axis here. That's where the acute line, theta hat would be. I've got to be careful how I say this. When working out the coordinates, we've got to be careful that if we're finding equivalent values, that theta hat is trapped between the x-axis and the unit line. So we don't tend to use the angle here or the angle here, for example, even though that's also acute, but it's the wrong spot to be looking at. There are exceptions to that, and that's part of what we need to learn this year. But effectively, these are the spots we need to start with. So before I move on, does anyone have any questions about conceptual questions about this, or but what if kinds of questions? I can think of a but what if. I can think of two of them, actually. I'll see if I can get the what if from you. I think I've proven quite thoroughly to you that it is absolutely possible to work out an x and a y coordinate, and therefore a sine, cosine, and a tan for everything here from 0 round to 2 pi. So, ... Thank you. What about beyond 2 pi? That's one thing. Also, this is the more tricky one. What about less than 0? What did you say? Going backwards, or less than 0. And actually, can we put both those facts together? When you're given a negative angle, go backwards. Yeah, that's what you do. So let me take angles beyond 2 pi to start with. If I had 3 pi, then that would be 2 pi would get me all the way around once, and then another pi would get me down, get me across to here. Okay? So effectively, the reason why I don't spend too much time talking about beyond 2 pi is that if you've got beyond 2 pi, all we do is just take off multiples of 2 pi until we're back to it, because the angle measurement for going round 50 million times and ending up here is effectively going to be giving me an xy coordinate as if I just looked at it from here. So if I've gone for 50 pi, I just have to cycle around 25 times and I'll end up there. So that's going to be the equivalent of sine, cosine, and tan of 0. It's going to be the same xy coordinate. Okay? Is that okay? Negative, as Sophie said, you go backwards. So if I've got the sign of negative pi on 4, then I'm just going to start here, but instead of going clockwise, anti-clockwise, I go... No, that is clockwise, isn't it? No, it's anti-clockwise. Instead of going anti-clockwise, I'm going clockwise, so I just go from here, having a moment there, senior's moment, negative pi on 4 would just get me into this quadrant. So whether it's positive or negative angles, whether it's angles that are a million billion degrees, ultimately the circular nature or the cyclical nature of sine, cosine, and tan means that I'm just winding around until I hit one of these quadrants. Then I'm working out what theta hat is, and then from theta hat, I'm working out what sine, cos, and tan is by putting a plus or a negative onto it. Okay, I need to do examples to illustrate it, but in terms of the concepts there, is that okay so far? Yep, okay, awesome. One other thing too, which is another what if, that's all well and good, but what if there is no gap between the unit line and the axis, i.e. what happens if it's along one of the axes? You'll see on your exact values chart here, we've got pi on 2, sine of x is 1, cos of x is 0, tan of x is undefined. Pi, which is the x-axis on the other, there's 0 as well, 0, 1 and 0, 0, negative 1 and 0, 3 pi on 2, but you can see they're just values between 0 and 1. Now that's really important to remember when we start thinking about sine, cosine and tan graphs as well, well not so much tan, but sine and cosine. Notice that every single, I hope you can notice, every single value of sine and cosine is between negative 1 and 1. Now, it's unacceptable for you to find that the sine of an angle is equal to 3.7. It's done because you make a mistake somewhere in the line. Making mistakes is acceptable. But when you get 3.7, you should be going, that can't be right, because sine and cosine is between -1 and 1. So please remember that. And the reasoning for it's, I hope, really straightforward. If they're coordinates, pi on 2 is going to be straight up here, right? A right angle. And here the coordinates would be, the x coordinate would be 0, and because it's a unit line, the y coordinate is 1. So the cosine of pi on 2 is 0. The sine of pi on 2 is 1. The tan of pi on 2, what's a vertical line? That's an infinite gradient, so it's effectively undefined. Go to here, we've got this, we've got the coordinates along here are -1, 0. So the cosine of pi is -1. The sine of pi is 0. The tan of pi is also 0 because it's a flat line, no gradient. And we can keep on going around and do the same thing for each of those. So yes, there is a chart that you can look up and make sure you're getting it right for sure. But also a real strong connection with these are just coordinates on the unit circle, which means the total distance out is always going to be just 1. That will really help you make it really solid what these trig values are. Okay, and there's the usual cast diagram here. You can see I've got number 1, work out the sine, cos and tan of theta hat, and number 2, work out if the result is going to be plus or minus. There effectively are 2 steps. We covered them last year. This is just a reminder of that. Okay, so what I want to do now is go through a couple of really simple examples that get you into doing some practice work. Again, I don't think this is much different from last year, so it's just a bit of a refresher. So example 1. This is my method of doing it. Let's just say you are asked to find the cosine of 5 pi on 4. It's a beautiful thing. First step, draw the diagram. You don't have to write number 1, but I'm just doing it for the video. So where is 5 pi on 4? What you have to get really good as a method student is, again, your fraction work and understanding which quadrant we're going to land on. So 5 pi on 4 is 4 pi on 4 plus another pi on 4, right? So you split up that 5 pi on 4 to pi, 4 pi on 4, plus pi on 4. So we've got our angle, being here. I'll draw a different colour so we've got it. Okay, so that is pi on 4. This is 5 pi on 4. Are we okay with that? It's kind of the hardest bit. Number 2, work out what theta hat is, well, in this case, the cosine of theta hat. So I don't think I'd probably quite write it the same if I was doing it for real. I'd probably just go straight to, I'll tell you in a second. So cosine of theta hat is equal to the cosine of pi on 4. I'd probably just start with that, to be honest, team. But if you want to reinforce in your brain, I need to work out theta hat first, that's what you do. Theta hat is always an acute angle, okay? So cosine of pi on 4, and that's when you, pi on 4, cosine, root 2 on 2. Write down root 2 on 2. With practice, you'll go, yeah, I know, 45 degrees, pi on 4, root 2 on 2. With practice, it's an important skill. Number 3, you then conclude, therefore, cosine of 5 pi on 4 is equal to negative cosine of pi on 4, which is equal to negative root 2 on 2. The textbook will have it as negative 1 on root 2. I'll explain that in just a moment briefly. I'll pause there for a moment and see. I'll give you a chance to write it down, then I'll take questions. Okay, so slide 14 there, top right there, that's actually how I'd write it. Just so you know, I wouldn't even bother telling you this, except that when you're checking your answers in the textbook, your answers are going to be different. So 1 on root 2, there's a method that all method students should know, and that is rationalising a denominator. We don't like to have a square root in the denominator, and I won't spend time today telling you why, but if you're curious, just ask. Rationalising the denominator, just the simplest form there is when you've got the whole bottom of your fraction as a square root. You just multiply top and bottom by that square root. And if I do that, I get 1 times root 2 on top, and I get root 2 times root 2 on the bottom. The square root of a number multiplied by itself is just that number. So in other words, 1 on root 2 and root 2 on 2 are identical values. That's how you do it. Okay, example 2, then I'll give you some textbook work to practice for a bit. Example 2, find the tan of 5 pi on 6, 52 pi on 6. Okay, so can we all agree that 52 pi on 6 is going to have a few spins in it? Like each spin is 2 pi, right? But because I've got a value here which is over 6, it's a lot easier if we can use our fraction brain to sort of translate 2 pi into on 6. So 2 pi, of course, is, with a 6 on the bottom, 2 pi, the equivalent value of 2 pi is what pi on 6? 12 pi on 6. Yeah, that I was fishing. I know you guys know that. I was fishing for an answer. You didn't know what I was trying to fish for. So, yeah. So what I do is I basically say how many 12s fit into 52 pi. And then you can use your 12 times half. Yeah, 4. 12 4s are 48. 12 5s are 60, so it's 4 times. So effectively, I would go tan of 52 pi on 6 is equal to the tan of 48 pi on 6 plus 4 pi on 6. So I've just split it up. And these, that is 48 pi on 6, which is 4 lots of 2 pi, effectively, which means that I'm basically going 1, 2, 3, 4, back to 0 again. Then I'm going to do that. So that's effectively the same as saying the tan of 2 pi on 3. See what I did there? 4 pi on 6. Simplify it to 2 pi on 3. That's what I'm going to deal with. So the problem tan 52 pi on 6 is actually the same problem as what is the tan of 2 pi on 3. Oh, that's good. I can do that a lot more easily. So I'll do it. I'll just go over to the side and do my cast diagram. 2 pi on 3. Looking at the number part, can you see that's 2/3 of pi? So 2 on 3 is the number bit, 2/3 of pi. So I'm going to have it here somewhere. That's 2 pi on 3. So I need one more to get to pi. So my acute angle is pi on 3. So I'm going to say tan of 2 pi on 3 is equal to the tan of pi on 3, the acute angle, and I'm in the second quadrant, which is where the gradient is negative, and therefore the value is going to be negative, and tan of pi on 3 is root 3. So I get negative root 3 and I am done. Questions? This is your thinking time for questions. No, don't do all of them. The learning schedule is coming, team. I just wasn't too sure about the pacing, so I wanted to sort of have a couple of lessons first before I committed anything to paper. Okay, I'm going to stop the video there for now. No, I'll stop the video and